I did this is we keep on pulling out crunch bars. You have an endless supply of crunch bars.
So this is the first one. This is the first one that I work out. And I have a number line test on the first one. I have a number line test on the second one. I sketched the thing according to this. Again, I'm going to do this again. So I use the inflection point as the cross sign. So I'm going to draw a smile face here for the minimum because this is the minimum at -1, -1. And I hear it's going to be an inflection point, inflection point. I find out original function. This one is going to be decreasing concava, so I'll draw a dotted line first. Once I've drawn the dotted line, I can use the concavity to sketch everything. So this is the concavity, concave up. And after the cross sign, it's going to be concave down and then concave up. So this is my first graph. A lot of you guys have fear of graphing. Guess what? I won't penalize you a lot if you not go into graph. You gotta go in to graph it. You cannot just find all the information and refuse to graph. The whole idea is finding all this information is to graph it. You cannot just be afraid of it and just say don't graph. I think most of math students, they have two fear. One's fear of word problem. One's fear of graphing. If you can conquer those two fears, then you can actually do fairly well because you learn from your feedbacks. Once you got it wrong, you go back to check what is wrong with it. Oh, I make a sign mistake. I did a number line test wrong. Those things you have to pay attention to. This one, I got my first derivative of 9 minus 2x squared over 9 minus x squared to the -1/2. I did my number line test. I got negative, positive, negative. Decreasing, increasing, decreasing. And I do the second derivative. It gets kind of messy, but I got, eventually I got the second derivative looks like this. Now I did it kind of fast. I don't know if I make mistake, hopefully not. I factored out a 6 as well. And then I'll go ahead and graph it. And this will end up to be graphed like this. Because the domain of the original function, you cannot plug in anything that's greater than 3. Because if you plug in 4, it's going to be square root of a negative number. A square root negative number is not able to graph it. Very good question. On tomorrow's test, you are for sure going to get a question like this. Using mean value theorem to find the value of C on this particular question. So let's see if you guys remember how to do mean value theorem. That's the only thing I'm worried about. You don't remember how to do mean value theorem. I need to make sure all you guys know how to do mean value theorem. Mean value theorem is on every single damn test on AP exam. Every single year, there's always the mean value question. You have to know how to do it. Rolle's value theorem, not as much. Mean value theorem is one of the questions always asked. Equal to what? F prime C. Yeah, you got this alpha C. I remember I did this question in the notes, but don't look at your notes and figure out how to do it. Yeah, so this is one of the questions that you will see. This question show up on tomorrow's test. You gotta know how to do it. One thing I will say is mean value theorem is like the most important thing besides curve sketching. So this question is on the test. Do you know how to do it? Tony, what'd you get? It does.
With it, 6/6.
No.
Okay.
Jack, what'd you get? I don't think so. Oh boy. Aiden, what'd you get? Or Josh, what'd you get? 1 3/4.
Fine. What's your answer, Dylan?
Avilash, what'd you
I got
get?
that.
-1/4 is right.
-4?
-1/4.
Oh, -1/4?
Wait, you set it to 0 after
You're not supposed to set it equal to 0.
You set it to the original equation.
No, you're not supposed to set the original equation. You have to know your mean value theorem.
F prime of x equals
negative.
yeah, equals the slope. Right?
And wait, wait, even else. What did you do after? I got -1/3 after.
You do f prime of x equals -1/3. How do you get -1/3? What did you do to get negative?
Yep, we did this.
Right. Yeah, but I did. I severely messed up. I what?
What am I trying to close and then you set it?
Oh, did you see it?
Then you just get to make it so that this equation equals -1/3. I just did it wrong.
Which equation?
F prime.
Oh, this is
Yeah.
Oh, shoot. Oh, that makes
Yeah, I messed up.
Simplified. -3/9.
Oh, the whole classroom got this question right, wrong, except one person. That's bad.
Oh, okay, yeah.
1/2.
Makes sense, but you gotta be able to do it tomorrow.
Oh, wait, I think I see something.
I just solved the first one.
Right? Right? There's -1/4. Oh yeah, right, first time.
Just solve an equation. The algebra part is what's, yeah. That's what a C value where the tangent line at -1/4 is equate to the secant line between two endpoints.
I got -1/4.
That's right. But why did you get it before?
I believe you wrote that back yourself.
It is like the same process, except for -3/9, I accidentally simplified it to -3.
Oh, it's like, oh, me at 3 to 1. This is my writing. And then me.
Tomorrow's test, yes.
When you get at -7, it's not plus or minus.
What?
I don't think when you plug -7 into the
What?
I don't think so.
-1 over 4.
9.
Rule 9 is 3. So there's a difference between x squared is equal to 9 and x equal to plus minus √9. This is plus minus 3. But x equal to √9, this is only in 3. Because you're not square root both sides. If you square root both sides, that's where you create plus minus. If you just x equal to square root 9, square root 9 is just 3. It's not plus minus 3. Because you just square root 9 is 3. That's it. There's no -3. It's not plus minus.
Because you're not putting instead of putting
Called, oh, is it?
That's always a most
Oh no.
very
So sorry.
misunderstanding is people thought square root 9 is plus minus. No, square root 9 is only positive 3. Square root 4 is only in 2. What?
Why?
Square root of 9 is only in 3. But x squared is equal to 9. X equal to plus minus square root of 9. That's why you get plus minus 3.
Oh, okay, makes sense. Yeah, I never understood that.
Because square root both sides, where you get plus minus.
Okay.
Now, there's another reason why, because some people think this is true, but it's not true. What is square root of -3 times square root of -3?
square root negative. Oh no.
So there's something to do with I because there is not like
No, just -3.
no, it's
It's only
Not nine,
-3,
right?
not positive 3. So this is what I'm trying to say. There was a hidden rule about this. Some people says, oh yeah, I can multiply those together, be square root of 9, square root of 9 is 3. But technically the hidden rule is wrong, because the hidden rule also say if they're both negative, then you have to change to square root of -1 times square root 3 times square root of -1 times square root 3. And this is going to give me I, and this is going to give me I. So that's going to give me I squared, square root of 3 squared, which is 3. And I is going to be, so it's -3. So this is -3, not positive 3. So therefore, the answer is only positive 3, not -3. Kind of confusing. It's one of the things that everybody asks every year because the algebra teacher is not teaching it correctly. And so those questions should be answered at algebra 2 level, not calculus level. Okay. So here we're gonna for the next test come in. So not this test. The test is tomorrow, by the way. You have to be able to graph something like this. Now this is more advanced questions. it turns out you don't need it very advanced to graph this. If you are really good pre-calc student or have a very good pre-calc teacher, let's just say none of you guys have very good. I mean, Cooper is all right. Cooper is good enough. But like Chaparro is very good. Cooper is good. I think one other teacher didn't cover all the things. I think he tried to cover, but as the information not solidified in people's brain. So one thing I will say is you do have to know how to graph something like this, even without pre-calc or without calculus knowledge. So people should be able to graph almost correct without calculus knowledge. With calculus knowledge, it can solidify a certain spot as inflection point or whatever. So we're going to talk about what if I just have pre-calc knowledge? Can I graph this? It actually can, because in terms of this, f of x can give you a lot of information, can give you x-intercept, can give you y-intercept, can give you domain, can give you, it doesn't give you range, but it does give you vertical asymptote. So vertical asymptote. For calculus, does give you horizontal asymptote, but again, that in pre-calc should give you horizontal asymptote as well. It's just different method. It can give you slant asymptote, which is also known as oblique asymptote. So in original function, I have all this information and plus the M behavior. So M behavior, it should be enough to graph this full function without calculus skill. With the derivative, you can find out it's increasing versus decreasing. You can talk about maximum and minimum. Okay, you can find all this thing. F double prime of x, you can tell me concave up or down. And you can tell me the inflection points. So inflection point, then this should be enough to graph. And then graph. You should be enough to graph. So let's talk about, and this one I won't talk about one more, is even versus odd. A lot of you guys don't know how to find even versus odd. If you have a good pre-calc teacher, it should solidify that knowledge already. Even function, odd functions.
Isn't based off like exponents or something?
It's not just based off exponent. It's a little bit trickier. So we're gonna talk about that. Huh? Degree, yeah, but it's like I said, it's a little bit more tricky. So x-intercept. Can you guys find me an x-intercept? No. What? Plus minus what? No.
Plus or minus 3.
Plus minus 3. Good. X-intercept is, if you want to know, is when y is equal to 0. This means y equal to 0. Means numerator of f of x equal to 0. Same thing. Because you can do x squared minus 9 equal to 0, x squared equal to 9, x equal to plus minus 3. So it's going to be negative 3, 0, union 3, 0. So those are the 2 points, 2 x-intercepts. How do you find y-intercept?
0.
Plug in what equal to 0?
X equal to 0.
X equal to 0. So if x equal to 0, I'm going to get 0, comma 18 over 4, which is roughly is same thing as 9 over 2. Would you say? Domain. How do you figure out domain? There was 2 things that you need to pay attention to domain. Domain is either denominator equal to 0, or cannot equal to 0, denominator cannot equal to 0, or inside the radical has to be greater than 0. So in this case, where's the domain at? No.
It's negative infinity to negative 2, negative 2 to 2, and 2 to infinity.
Really good. Why? Because domain is basically check where cannot equal to 0. So this cannot equal to 0, x cannot equal to 4, x cannot equal to plus minus 2. So x cannot equal to 2, and x cannot equal to negative 2. That is going to be one of the thing. Did anybody know what happened to Catherine? Have you seen him today? Yesterday? Last week? Last Friday, she's already not here. She was here Friday? Huh?
I think so.
How do you know?
That's how I remember my interaction.
I also
I feel like
I was there.
you interact with her solely
You
on the basis
you
of
picked up a phone call
that
at
you
your
wanted
couch.
Is that Friday? I thought it was Thursday.
Feel pretty good about that.
Where's the vertical asymptote? The vertical asymptote sim is like this. So it's denominator equal to 0. So plus minus 2. That's where the vertical asymptote. Where's the horizontal asymptote? That's a tricky one. Who says 2? 2 is good. But there's a calculus way. The calculus way is limits x approach infinity of 2x squared minus 18. I just distributed x squared minus 4. Why I use calculus way? Because this case we are learning about calculus is limit x approach infinity. Limit x approach infinity is going to give you 2x squared over x squared, just divided by top and bottom by x squared. When limit x approach infinity, this one's going to cancel out. So that'll be 2 over 1. So that's 2. So y equal to 2. That's horizontal asymptote. If you have horizontal asymptote, you don't have vertical, you don't have slant. And behavior, we're not going to worry about that because in this case, it's just going to reach to 2. Even or odd. How do I know this is even or odd function? Well, the best thing is plug in negative x into the original function. If you come back to normal original function, then you are even. If you come back opposite, then that's odd. So negative x, so everywhere you have x, you replace that. So it'll be 2x squared minus 9 over x squared minus 4. So that looks like original function. That's even. And even has the symmetry of y-axis. So symmetry of y-axis. Got it? Okay, increasing versus decreasing. I had to do number line tests. But I need to figure out what my derivative is. So f prime of x, I'm just going to write down a derivative because I'm too lazy to actually work it out. But you should be able to work out to get to this point. (20x over x squared minus 4 squared). That's after you take a derivative. Now, do I need to do number line test on the bottom? You probably still need to do -2 to 2. And you had to do 0 as well, just because there's an asymptote. The asymptote is going to affect the increasing and decreasing. So I'm just going to do 20x here. This one is going to be minus sign, I think. Minus sign, plus sign, and plus sign. So the increasing, no, sorry, decreasing. Decreasing, decreasing, increasing, increasing. So this 0 is a 0, 9 over 2 is a minimum because it went to decreasing and increasing. Second derivative. The second derivative is equal to, this one's actually interesting. So it's equal to -20. I want to talk about this one a little bit more. So 3x squared plus 4 over x squared minus 4 to the third power. So if you do it correctly, this end up to be like this. Now, here's my question. Do I need to do a number line test for this part? The part I circle. Irby, why not?
Because it's the same value as the bottom.
It's not the same value. It's not why. Always positive. Tony says always positive. In here, it doesn't matter what I do. So I don't need to care about that. The things I need to care about is -2 and 2. Now, -20 gonna affect all the sign though. -20 gonna give you all the sign negative. Is that okay? Because -20 gonna affect everything here. X squared, sorry, I'm gonna test the bottom. It's x squared minus 4 to the third. This one's positive, this one's negative is positive. So it's gonna be positive, negative, negative. So it's gonna be down, up, down. Now it's -2 an inflection point. That's a tricky question, by the way. Is -2 and 2 inflection point?
Because it's
Shouldn't the first one be positive because it would be negative of a negative number? Or no, sorry, just -20. Never mind. Ignore that.
it doesn't have to be like
So it's -2 and 2 a inflection point. The true answer is no, because -2 and 2 are asymptotes. So you always have to check the original function. Are they the actually valid point? Because they're not fit in domains, right? So now we're gonna go ahead and sketch this graph. What time we get off? Oh, I have a lot of time. 8 minutes? I have a lot of time. So -2. So -2 is going to be an asymptote. And +2 is going to be asymptote. And the 0, and there was an asymptote at, there was x-intercept and y-intercept at this point. And there is 9/2. I don't know, 9/2. I think it's 9/2 is right here. Now this is a smile face because according to here, this is a minimum. So the function is going to go, according to this, it's going to be down. Oh, there's a horizontal asymptote. Where's the horizontal asymptote? 2. So 2 is right here. So there's a horizontal asymptote. So let's look at a -3 region. -3 region is going to be decreasing and concave down. So decreasing, concave down. So only one that's going to decreasing, concave down is going to be like this. So this decreasing and concave down. And it's going to follow the asymptote because asymptote is not something you can reach. So once you go close to asymptote, you're going to, it's like a strong current. It's going to flow down accordingly. You flow to the left, it's going to flow to y equal to 2. So it's going to have a plateau. Now in here, if you flow this way, it's going to go up because it's concave up and decreasing. So its function is decreasing, concave up. And this is also concave up, but it's increasing. So it's look like this. And here it's concave down and increasing, so it's going to look like this. So the graph is going to be like this. And that's going to be one of the graph that you're going to have to do on the following test. But this test, you just have to be able to graph polynomial. What's on the test? On the test, you're going to have all this stuff. Can you find the extrema in the interval using table? That means critical point and endpoint you have to plug in. Mean value theorem, we just practiced one. You have to know the condition for mean value theorem to be true. Rolle's value theorem. Critical point. Can you find critical point? Two type of critical point. Derivative equal to 0 or derivative equal to undefined. Increasing versus decreasing. If you know how to graph yesterday, increasing, decreasing, that should be no problem. Max and min should be no problem. Up and down should be no problem. Inflection point should be no problem. Number 9. It's going to be first and second derivative test. The first derivative test is check when they change in positive to negative, that's going to be relative max. Second derivative test is the Karate Kid. Karate Kid is concave down, so it's a f prime of x is equal to 0. So let's just say f prime of 2 is equal to 0. But f double prime of 2 is positive. So it's a relative minimum or relative max. Second derivative is positive. It's a relative max or relative min. Relative minimum, thank you. It's going to be phased like this because second derivative is positive. So sometimes you're going to get a very easy question like that. And you're going to figure out how to use second derivative test. Because the concave up and you got horizontal tangent, that is going to be relative min. Analyzing f prime of x, you got to do above x-axis, below x-axis, figure out what that graph is. Curve sketching, you're going to have a point about that. Number 12, I really like this question on one of your worksheets. It says, find the equation of tangent line at an inflection point. Oh boy, you had to do all kind of things. You had to find out second derivative equal to 0. In that x value, you had to plug in the first derivative. And I had to plug in the original function to find the equation tangent line. If I ask you standard form, then you have to solve for standard form. That becomes even more challenging question. But yes, you are going to have a question like this, just like your worksheet. Go back and look at all your worksheet. I think the worksheet you should look at is the stuff is more furthest away. So furthest away is like this one. This one has all the finding critical values, finding Rolle's value theorems, mean value theorems. This one's really difficult. I think we go over that one. Number 4 is really difficult. And the last one. I really like this 2 question. This 2 question will be a good review of what are you supposed to do. And this question I put on the BC test. But I'm not going to put on the AB. But this one is pretty hard. This one is I actually just put it directly on BC test. And this one is I actually put on BC test as well. But you guys test is not going to be as high level difficulty. Next year, maybe. So maybe harder. Next year you're taking BC.
Yeah. Go back to the list of everything that's going to be on the test.
Yeah.
Can't do that.
What are you talking about?
You have to put the lead on the outside.
Usual. I think it could be called a century. It's still like that. There's some high. I guess it's even more.
What is number 9?
It is?
Second derivative.
It's due tomorrow. Tony, do not. Tuesday, no? Tuesday, 11. Bro, I'm not able.
Analyze.
Why did you actually make my heart stop for a second, brother? You're not even yapping about like hippos.
Is that interfact for integrity? No, but it is fine.
Oh, karate switched him into thinking like he was eating glass and switching out See, that racist.
My partner.
Your name is
What is it?
No, because I asked karate to switch in class. He's like, oh, I'll work on it. Like a week later, he switched Nathan. But he got Nathan. Yeah, but I think he, like, because he knows both of us, So then he probably just like try to remember it. And then when
CJ, what does 11 say?
11 says curve sketching. Are you gonna tutor him today? He said he needed help. I don't know this kid.
I was here once before.
Oh.
It's only basketball.
No, mean value theorem, mode value theorem, all the stuff. Critical points, increasing, decreasing. They don't. She need help.
I rewatched it. It's like, and then I read it. I really like it.
She's behind.
No, trying to catch up.
Oh my god.
Trust.
Can you stop saying that word? Drive me crazy.
Trust.
I cannot trust.
Trust.
No trust. No trust. It's a cap. No, okay, stop saying that. Drive me insane. No. I trust the result. What's your name?
Justin. From my homecoming. Yeah. I had Mr. Cooper for both.
Yeah, I heard. I met your mom before.
Yes. She likes to chat, doesn't she?
Yeah, she is. What'd you get on the IP exam? And what are you taking right now?
Different.
With who? UCF or UF?
Valencia. I want to go in person.
Oh, you go in person?
Yeah.
Who's the teacher?
Dr. Seifel.
I know one teacher there.
Yeah.
Dr. Tashan. She teaches at Bones High School. Do you think it's better than better teacher than we have here?
So, it's hard to compare, you know, because Mr. Cooper, at least when I had a he taught a theory behind calculus, which I like, you know, it helped me have a deeper understanding of material. But my current professor, he just like kind of quickly teaches us the method to solve it and then moves on. And I know how to do everything, but it's kind of like the applications aren't as strong.
Yeah, that's Valencia for you. Because the most of students are not very high level.
But
if you have dual enrollment will be a little bit better.
I did the Calc 3 through UF and I didn't like it. Like it was very hands off from the professor, and the videos were like way older than I was, so it was very hard to learn.
Way older than you are.
Yeah, like I think they were filmed for up to.
That's so funny. That's horrible because the